random variable. So that's an example of a discrete random variable. And next I want to look at the Poisson random variable or distribution. And that's also an example of a discrete random variable. Now, you would typically apply the Poisson distribution if you have events that occur over a certain period. So remember, for binomial, you needed to have two possible outcomes. Now, the key to the, if you get a question that asks you, to find the probability of an event happening over a certain time interval, then you're going to apply the Poisson distribution. And typically they would give you the average number of cases that something happens in a time interval. And then you can apply the Poisson distribution. Okay, so let's take a look at an example. I think that might be the easiest. So this is an example from your notes. I posted these notes under module 10. So they state here, a statistician records the number of cars that approach an intersection. He finds that an average of 1.6 cars approach the intersection every minute. Assuming the number of cars that approach this intersection follows a Poisson distribution, what is the probability that 3 or more cars will approach the intersection within a minute? Now, you can read more about the theoretical background of the Poisson distribution. Basically, for binomial, we had two parameters. So the parameters were n and p. N would be the number of trials, and p would be the probability of success. But for Poisson, you're going to have just one parameter, and we typically use lambda to denote that parameter. Now, we use Greek letters because the Greeks contributed quite a bit to mathematics during Euclid's time. So that lambda is just going to indicate the average number of events that occur in your time interval. So in this case, they tell you that the average number of 1.6 cars, so your lambda in this case is going to be 1.6. And then they ask, what is the probability that 3 or more cars will approach the intersection within a minute? So given that your average number of cars is 1.6, what is the probability that 3 or more cars will approach the intersection within a minute? So in this case, you want to find the probability that x is more would be greater than 3 or more, so it's greater than or equal to 3. So you want to find the probability that x is greater than or equal to 3. Now, note that if you have a discrete random variable, then the equality sign is actually very important, because you can find the probability that x equals 0, the probability that x equals 1, the probability that x equals 2, the probability that x equals 3, the probability that x equals 4. So you can find all those specific values, and they will add up. Whereas for a continuous random variable, it wouldn't be that important because you're really finding the integral under the curve, and for the integral of a point is just equal to 0. So we will get to continuous random variables a little later, and that's where we will apply quite a bit of calculus. But for now, just know that if I ask you the probability that x is greater than or equal to 3, then you have to include that equality sign. It's actually important. And we will see now. Let's take a look at how to solve this using the GeoGebra platform. So you can go to geogebra.org, and then from there, let's see, you're just going to pick GeoGebra Classic, and then from there you can pick the probability calculator. Okay, and this calculator will actually give you all the distributions and more. We're not going to do all the distributions in this class. If you will take a graduate class, we will take a look at the rest of the distributions. But for now, we know that we are working with a Poisson distribution. So we're going to pick Poisson, and you can use mu or lambda. It doesn't matter. Mu or lambda would be is convention in mathematics to use as the average number of events. So in this case, we know that it's given, my parameter is given as 1.6. That's the average number of cars that will approach your intersection per minute. So we're gonna make that 1.6. And then we want to find the probability that x is greater than or equal to 3. So that's what we are asked to find. What is the probability that 3 or more cars, that means the probability that x is greater than or equal to 3. So we're gonna just pick this square bracket here, click on that, the right sided square bracket, x is greater than or equal to 3. There you go. And there you can see. I mean, what's happening here is you have a discrete random variable, but if you take a look at this graph, you can see that for greater than 3, it quickly, it can, go up to infinity. X could be 100, x could be 200, x could be 1,000, right? But you're going to see that the Poisson distribution will very quickly become close to 0 for larger x. And this is quite evident from this graph. And so you can see here the probability that x is equal to 3 will be 0.1378. The probability that it's equal to 4 is 0.0551. But you want to know each of those occurrences, right? So you're really looking at the probability that x is equal to 3, plus the probability that x is equal to 4, plus the probability that x is equal to 5. And you're going to continue like that, and GeoGebra added all the events for you, so it's going to be 0.2166. So this is how you will do it with the GeoGebra platform. But, let's just make sure that we know how to apply the theory. And if you take a look at my notes, I would highly recommend that you read the notes. I try to be very concise, but you will have to know how to apply the formula on the final exam. I will give you the formula, so you don't have to memorize the formulas, but it will be very important that you know how to apply these formulas. So let's take a look at the notes, and I provided you with a formula, and of course it's just going to say the probability that x is equal to some value k, or you can write small x, it doesn't really matter. Let me see what notation we used in the notes. So here are the notes. They are posted under module 10. They are posted under reading, and we're basically doing both a binomial and Poisson, but we're applying the formulas right now. So the second part will be on the Poisson distribution. And if you take a look here, here is the formula. The probability that x is equal to k is going to be lambda to the power k. Your lambda is now your average value, right? E to the minus lambda over k factorial. So let's write it. Probability that x is equal to k is going to be equal to lambda to the k e to the minus lambda over k factorial. So if you would do it by hand, you would have to go and find the probability that x is equal to 3, right? And then you plug it in. It's going to be lambda to the third power e to the minus lambda over 3 factorial. Now, we know what lambda is. Lambda is your average number. So that is given as this 1.6. So you can plug that in. It will be 1.6 to the power 3 e to the minus 1.6 over 3 times 2 times 1, right? And so basically you can use a calculator now and find what is 1.6 times 1.6 times 1.6. That's going to be 348.16, and then e to the minus 1.6. Let's see, we could just use algebra here. let's see. So we're going to have 1.6 to the power 3 multiplied by e. Oh, sorry. That should be like this. Multiplied by e to the power, what was it? Minus 1.6. Minus 1.6, and then, okay, and, oh, no, to the power minus 1.6. And then you want to divide that by, so this is going to be 0.827 divided by 6, right? Because that's the 3 factorial. So that's going to be 0.137. And let's just take a look at what we got for probability x equal to 3, 0.13. Yeah, so the calculators might round a little differently. The one might be more accurate than the other one, but minus 1.4, it's about minus 1.4. And then, but then you will have to add the probability that x is equal to 4 to that. So now you're going to find the probability that x is equal to 4, and that's going to be lambda to the 4th power, e to the minus 4 over 4 factorial. And you can work that out. So that will be plus the probability that x is equal to 5, which is going to be lambda to the power 5, e to the minus 5 over 5 factorial, plus the probability that x is equal to 6, which is going to be lambda to the 6th, e to the minus 5, to the minus 6, and then over 6 factorial. And so you will see that those answers will become smaller and smaller and smaller, and, you know, basically be equal to 0. But that's how you could do it. Or you could do it by using the complement and say, well, the probability for that x is greater than or equal to 3 is the same than 1 minus the probability that x is less than 3. Right? Because, I mean, all probabilities have to add up to 1. And then in this case, it might be easier. You can say it's 1 minus the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2. So that might be an easier way to do it. And so then you will get 1 minus the probability that x is equal to 0. Now you're going to plug in for 0, so it's going to be lambda to the power 0